The contents we are going to look are the weighted code, BCD or 8421 code, the non-weighted code, gray code, decimal to BCD conversion, binary to gray and gray to binary conversions, ASCII code. Binary coded decimal is a weighted code as it bears weights at every position. For example, the decimal digits in column A and the 8421 equivalent of the decimal digits shown in the table indicates decimal digit 0 equivalent to 8421 code as 0000, decimal digit 1 as its 8421 equivalent as 0001, and so on it continues, and decimal digit 9 is equivalent to its BCD code or 8421 code as 1001. Note here that the bit A0 is the least significant bit and bit A3 is the most significant bit. Let's convert the decimal number to its BCD equivalent. The decimal number 278, when needs to be converted into its 8421 equivalent or BCD code, then each decimal digit is converted into its 8421 equivalent, and altogether the total bits forms the answer. In the second example, let's convert the decimal number 2709 into its BCD equivalent. Here too, each decimal digit is converted into its 8421 equivalent, and altogether all bits forms the answer, that is BCD equivalent of the decimal number 2709. Decimal, binary and its BCD equivalent are shown in the three columns respectively. Column 1 indicates base 10, that means these are decimal numbers. Base 2 indicates binary equivalent of the decimal numbers, and in the third column, BCD number indicates the BCD equivalent of the given decimal numbers. The point to be noted here is that from decimal number 0 to 9, the binary equivalent and the BCD code are one and the same. But from decimal 10 onwards, the binary equivalent is different and the BCD equivalent of the given decimal number are different. For example, decimal 10 has its binary equivalent as 1010, and decimal 10 has its BCD equivalent as 0001, 0000. The figure here shows the application of the BCD code input in 7-segment display. For example, the BCD code input 0001 displays decimal 1 on the common cathode display. Let's convert the binary code into its gray code equivalent and vice versa. Although gray code is not suitable for arithmetic operations, it has some applications such as analog to digital converters, error correction in digital communication, in labeling the axis of Karnau's map, etc. For example, the given binary code is 1100. It is to be converted into its gray code equivalent. Initially, the most significant bit of the binary code is taken as it is as the most significant bit of the gray code. Secondly, the two successive binary bits are added to generate the sum and a carry. The sum is considered as the gray code bit and carry is neglected. Similarly, the successive next two binary bits are added, sum is considered and carry is neglected. In this way, we obtain the gray code output. Note here that when addition of binary bits is performed, the carry is neglected and only the sum is considered as the gray code output bit. Now let's convert gray code to binary code. The gray code is G3, G2, G1, G0, where G0 is the least significant bit and G3 is the most significant bit. In this case, the gray code most significant bit G3 is taken as it is as the most significant binary bit. Further, the obtained most significant binary bit is XORed with the gray code bit G2 to obtain the binary bit B2. Similarly, the binary bit B2 is XORed with gray code bit G1 to obtain the binary bit B1. And then B1 is XORed with the least significant gray code bit G0 to obtain the least significant binary bit B0. In this way, the binary code B3, B2, B1, B0 is obtained. Students can take this table to perform binary to gray and gray to binary conversion. ASCII code. ASCII stands for American Standard Code for Information Interchange. It is a 7-bit code, meaning thereby 128 characters can be defined using this 7-bit code. To have the unique language for computers to understand, the ASCII code was introduced. These 128 characters can be assumed to be the 128 keys on the keyboard, wherein each key pressed represents a specific 7-bit code, and this is how the computer understands the key pressed on the keyboard. For example, for capital letter B, the ASCII code, that is the 7-bit code, is 1 4 times 0 1 0. Similarly, for capital L, capital U, small alphabets, small e, and so on. Students can take this assignment and become expert. Let's conclude. We had a quick overview of the weighted code, BCD or 8421 code, the non-weighted code, the grey code. We studied few conversions, decimal to BCD, binary to grey, and grey to binary conversion. And we had a quick overview of the ASCII code.